for coming. We're sorry for a little bit of technical difficulty, but thanks for your patience. And we're glad that you're here. I'll be sharing my screen now, and we'll be talking about how physics applies to climate change and also to solutions that we can use to address climate change. And we welcome your input and your questions, and we will be monitoring the chat, so please feel welcome to ask questions. Okay, so hopefully everybody can see. Please let us know in the chat of YouTube if you can see the slides. Hopefully everybody can. If you have any trouble, just put a little note in YouTube. So this presentation is in conjunction with the Physics Fair and Science Expeditions. My name is Susan Nossel, and I use she, her pronouns. I work in the physics department. I work as the director of our learning center and really enjoy working with students who are studying physics. And people study physics for so many different careers: medicine, engineering, physics, environmental sciences. I also work as a scientist studying atmospheric physics, and we'll talk a little bit about how physics relates to the atmosphere today. So again, thanks so much for coming. And let's see. And Liz, I think you have the YouTube in the new YouTube link in the Zoom chat. So thanks for putting it there, and also in the YouTube chat. So thanks to Liz, Jesse, and thanks to Steve Burns for helping today. So some of what we'll be talking about today could be a little bit difficult because it can be a little bit sad or a little bit scary when we talk about climate change, and that's natural. And also, there are many different solutions and different strategies that we can use, and which we'll talk about as well. And these strategies can help us to actually have a better world. So, for example, if we stop using fossil fuels or reduce the use of fossil fuels, then what can happen is that the air quality can improve, and that can be helpful for human health. And for example, if somebody has asthma, that would help them because then they'd have less pollution in the atmosphere, in the air. So there's benefits that can have strategies that can have multiple benefits, and there's many jobs, exciting jobs, especially that young people can have in the future relating to addressing climate change. Okay, so first we'll talk a little bit about how physics helps us to understand what's called the greenhouse effect. So this is a greenhouse, and an analogy is often made to a greenhouse. So sunlight comes through the greenhouse, and it's absorbed or taken in by like the plants, and that causes the greenhouse to warm up. And when the greenhouse warms, the all those objects give off what's called infrared light. We can't see infrared light except if you have a very special camera, and maybe you've seen an infrared camera before. So a greenhouse prevents some of this infrared light from going out to space, or going out of the greenhouse, going out into the air, into the atmosphere. Another way that the greenhouse causes warming is because there's a roof. And so when warmer air is rising, the roof prevents the warmer air from leaving the greenhouse. There's an analogy for the atmosphere, and it's what happens is that the sunlight passes through the atmosphere. It is also causes the energy from the sunlight causes objects at the surface to warm up, and then they give off light that's in this called the infrared light that we can't see, but that causes warming. And luckily, there are gases in the atmosphere that do trap or take in or absorb this infrared light, because if there weren't there, the atmosphere would be too cold to support life as we know it. So luckily we do have greenhouse gases in the atmosphere, but the problem is something called the enhanced greenhouse effect. And the enhanced greenhouse effect means that humans are adding more and more of these gases to the atmosphere, and that's causing more warming than we've seen in the past. So can somebody write in the chat, please, what are some of the greenhouse gases that are increasing due to human activities? Steve, were there any people, no, okay. You're also just want to say you're very welcome to guess too. Guesses are very appreciated, but I'll say that some of the gases that are increasing due to human activity include carbon dioxide and methane. Those are two that we talk about most in the news. So we'll talk about those in a moment, but this is what's called the spectrum of light, and this is visible light that we can all see. This is ultraviolet light that has more energy, and so concern with ultraviolet light coming from the sun is that it can actually cause us to get sunburned, and luckily the higher parts of the atmosphere prevent the ultraviolet light from coming uh, down to where we live, and prevent some of it from coming down to where we live, much of it from coming down. And so it helps us to prevent sunburns. And then on this side, infrared light is light that we can't see, but it's very important for the greenhouse effect and for energy balance in the atmosphere. And so carbon dioxide and methane are two of the gases that are increasing due to human activities. And talk about that here. So this is the years on the x-axis here, and this is how much carbon dioxide is in the atmosphere. We see a lot of wiggles. So I wanted to check to see if anybody knows why we might be seeing these wiggles. And please, we do appreciate any guesses is very appreciated. So if you want to put in the YouTube chat your thoughts about why we might be seeing these wiggles. Oh, good. Thank you, Ben, that said carbon dioxide is a major greenhouse gas. Yes. And this is carbon dioxide, and carbon dioxide is the main gas that's increasing due to human activity. So thank you for that. Any thoughts about why we see the wiggles here? So the wiggles have to do with natural variation, and they have to do with the seasons. So what happens like in the summertime, spring and summer, what do we have more of in the spring and summer? What's growing? Well, it's right now that we're starting to see spring, we're getting a chance to see a lot more green. And I know I always appreciate seeing the green after the winter time. So we are seeing, yeah, seasonal fluctuations is exactly right. So what we're seeing is thank you. So what we're seeing is that during the summer months, we have more plants. And so plants take in carbon dioxide and they give
I'm running a 40-second delay.
Is it that long?
Yeah.
It's like
give
40.
out oxygen. And
Yeah.
then,
So the YouTube people can't
Can't
interact
see it.
directly.
Okay.
You know what I'm saying?
oh, okay. Well, it sounds like there's more like there's a longer delay than I had understood. Okay, great. And plants, excellent. There's a 30-second delay. Okay, so, well, okay, that's good to know. So plants, thank you very much. So plants take in carbon dioxide in the summer and spring. And so that means that there's less carbon dioxide in the atmosphere. And this is what's called natural variation. And we also have the line going up, and that's what's called the trend. The line is getting, the amount of carbon dioxide in the atmosphere is getting larger. That's called the trend. And then the wiggles are called the natural variation. And while I'm moving to the next slide, so I'll give you enough time to put something in the chat. Could you, does anybody know why, like when carbon dioxide started to rise, what did that correspond with in terms of our history? Like what event, what big event happened at the time that carbon dioxide started to rise? And I'll let you put some thoughts in the chat while we look at this graph from NASA. This one is showing carbon dioxide in the atmosphere, and it's showing that the current level of carbon dioxide is much higher than it's ever been for centuries before. So does anybody know why the carbon dioxide started to increase so much? Actually started increasing in about 1850. Let's see. This is also with methane, we see that too. Anybody know, I'll look out for the chat in a moment, but if anybody knows what happened with the, we can see this in temperatures, what happened when in about 1850, what big event was happening that could have caused increases in carbon dioxide? So I'll give you time to put that in the chat. At the same time, I wanted to talk a little bit about temperature in the atmosphere and what we see here. Okay, so, gas. Yeah, so there were more gases that were added to the atmosphere, and that was due actually to the Industrial Revolution. So the carbon dioxide gas was added to the atmosphere, and thank you for the thoughts there too, added to the atmosphere corresponding with the time of the Industrial Revolution. So this is a graph that's showing temperatures over the last 2,000 years. And what we see is that we see a higher temperature today than we've seen over the last, cars. Okay, yes, cars are a big source of carbon dioxide. Thank you. So we see over the last 2,000 years that the temperature is at a higher level than it was anytime within the last 2,000 years. And one thing I wanted to mention here, it seems like 1 degree, this is in degrees Celsius. 1 degree Celsius, it sounds like such a small amount, and yet we're seeing wildfires, we're seeing more floods and droughts, and but 1 degree seems so small. But one way we can think about that is when we think about our human body, like if we have a fever, it might be only a few degrees. And yet, if we have a fever, we have a lot of symptoms. We can have a lot of symptoms. So there's a person, a really good scientist. Her name is Catherine Hayhoe, Hayhoe, and she has some good videos that show about what happens with just a small, it's called climate weirding, and what kind of changes happen to the atmosphere when we have a temperature change of 1 degree Celsius. So 1 degree Celsius is almost 2 degrees Fahrenheit, and that's temperature scale we often use when we take our temperature, to see if we have a fever. Okay, another issue is another point here is that the changes in temperature are not the same across the globe. So, for example, the darker the purple shows, the purple parts show the higher latitudes closer to the Arctic, and that there's more warming in those areas than there are in many other parts of the world. And we can also use physics to help us understand one of the reasons why that's happening. So I will stop sharing for a moment. And if you don't have to have this, but if you do have a flashlight or a white piece of paper or a paper bag, you can do the demonstration with me. Otherwise, I'll do the demonstration and you can look at the demonstration. So I will stop sharing for a moment and I will get my demonstration. Okay, so can you all, hopefully you all can see the light. This is a flashlight and this is a piece of paper, and the light is reflecting off of the white piece of paper. And now, let's see. We'll see it. This is when it's the paper bag. And this is when it's the white piece of paper. Which one is brighter? Is the light reflected off the paper bag brighter or the light reflected off the white piece of paper brighter? And you can put that into the chat. Again, I'll do it one more time. And you could try it at home. It doesn't have to be a flashlight either. Let's see. So that's the white piece of paper. Not sure quite how well it comes across on the screen, but that's the white piece of paper. And then the brown paper bag. You'd probably see it better if you did it at home yourself. I'll start sharing again. While I start to share, I wanted to ask if people could put in the chat whether they think like if the white paper is like ice and then the brown paper bag is like soil, which one do you think would cause more reflection of light? So why don't we please put that in the chat. Also, if you think of any other object that people often have around them, maybe in their homes, that reflects a lot of light, please put that in the chat as well. And I'll start sharing my screen again. Okay, so the white paper is what reflects the light more than the soil. White paper, which is like ice, reflects the water. Thank you, more than the paper bag, which has a color more similar to the soil. Also, open water in the ocean is darker and would also absorb more and absorb more light and reflect less light. So what's happening is that as the ice is melting, that means that there's less light that's being reflected back out to the atmosphere and less of the incoming sunlight, and that causes more warming. So that's one of the reasons why we see warming at the higher part, closer to the poles where there's more ice. this there is some cooling here in the ocean, and this is also relating to climate change because the ice sheets in Greenland are melting, and so they're adding cold water into the ocean. So, and when the temperature changes more in one region than another region, that can cause there to be patterns of changes in the oceans, the currents in the ocean, the way the ocean moves, and then also patterns in changes in the way the air moves in the atmosphere. And you might have heard something called polar vortex. I think it was the winter of 2019 that we had a very cold winter here in Wisconsin. Some a very cold, should say, we had a period of time that was very cold. And so when there's changes in the temperatures in the Arctic, that actually, then there's less of a temperature difference between the Arctic and the lower latitudes. That can cause what's called, that can cause changes in the air pattern, the patterns of movement of air in the atmosphere. And that causes that's one of the causes of thought to be one of the causes of polar air being colder polar air, sometimes making it down to the mid latitudes, like where we live. Okay, we just did the albedo experiment. I just wanted to mention too that that the some of the data that are taken to try to understand climate are taken right here in Wisconsin. This is on Lake Mendota in Madison, and there is scientists have been taking a record of lake ice for many years, and we can see lots of variation from year to year, but the amount of time that the lake is covered by ice is decreasing. It's decreased by about 1 month since 1850. Liz, since we started late, is it okay if we continue for another 15 minutes or so?
Absolutely, that would be just fine.
Oh, thank you. Okay, so I want to share a little bit about some of the changes that we're seeing. And this comes from a report that you can look up called the Intergovernmental Panel on Climate Change report from the United Nations. So some of the concerns is more days of hot weather, and that can be really hard on people's health, or some changes to water supplies and changes to, there can be threats to agriculture, and more flooding is some concerns with climate. I think let's talk a little bit more. One thing that's more extreme events, so more heavy precipitation events are, and also more droughts actually are also expected, and we're seeing them. There's another report that I want to mention, and they have a lot of stories about climate change. It's called Wisconsin Initiative on Climate Change Impacts, and it just was published this past February. There's a website, you can look that up, but it is saying that Wisconsin has become warmer since the 1950s, and it's become wetter. And there have been more increases in precipitation, like heavy precipitation events. And this can be of concern for many reasons, but if there's more flooding, that can be cause problems for agriculture. And so sometimes what we need to do is we need to do two different things. One thing is called mitigation, which means to try to reduce the amount of greenhouse gases in the atmosphere. And the other is adaptation, which means to try to create systems that are not as susceptible or to the changes due to climate change. So an example of that could be, for example, planting more trees. Planting more trees in in cities could be very good because the trees can take in carbon dioxide, and that's an example of a mitigation strategy, that big word called mitigation. That means it's taking in carbon dioxide. And also they can cause a cooling effect because the nice leaves from the trees can shade people from the sun, and that can cause cooling. So that's also adaptation. I also wanted to mention environmental justice concerns, that where fossil fuels are refined, there's can be a lot of pollution. And many of the communities that are closest to these refineries often are communities in lower income circumstances, and a number of them are communities with larger numbers of BIPOC or people of color communities. And so this is a really important social justice concern too. So if we need to we need to do a very fast transition away from fossil fuels for the climate, and also that will be good for people's health as well. And so I put in a couple of websites. The NAACP has information about environmental climate justice, and then Indigenous Environmental Network is another important website to look at, which is also emphasizing the importance of moving away from fossil fuels as quickly as possible. Additionally, in Wisconsin, a number of Indigenous communities are um, use wild rice is very important to a number of Indigenous communities, and wild rice can be threatened too. Their habitat can be threatened because of climate change. So now I wanted to turn to talk a little bit about oh, okay. So there's a question. Why are there gaps in data in Central Africa, South America? Um, okay, very good question. So early 1900s. So and where did data come from if not from satellites? So so we can go back to that in the temperature change data slide, and I'll see. I think that's. Thank you for the question. So this one, they're saying, why are there data gaps, and where did the data come from if not from satellites? So that is a great question. And I actually don't know I don't want to tell you the wrong answer. I don't know for sure where the data came from in terms of in the 1900s, that's the early 1900s. That's a very good question. I'm thinking that it's coming. I can share with you some guesses, but I just think that we'll have to go back and look to make sure this is the case. Could have been thermometer readings in different parts of the world that were used to track the data earlier on, plus tree ring data. So tree rings, you can get information about temperature from tree rings, and um, and some of the earlier data that are from carbon dioxide emissions or other gases, the way that temperature is, the earlier data are obtained regarding gases in the atmosphere is by scientists drill down in the ice, like in glaciers, and the lower down you go into the atmosphere, into the ice, if you go farther down into the ice, that corresponds with older years. And so gases are trapped within bubbles within that ice, and that ice can be melted, and then the gas within the ice can be analyzed to find out what was the composition of the atmosphere years back in our history. Maybe afterwards we can talk a little bit more about the question too. Thank you for that. Okay. Oh, and I think before we turn to what we can do, I also, and how physics can help us with that, I also want to mention that scientists are studying global patterns of changes. Where you see changes at different parts of the globe, and in like in precipitation and temperature and maybe different kinds of plants. And and then they're comparing these changes that they're observing to models that are created by a computer that have a lot of equations in them. So if you like computers, that's also a way to get involved in climate science by making predictions with a model. Um, and the part that I work on is trying to contribute in a small way to scientist studies, which are looking at different patterns as you go higher in the altitude, vertical patterns of changes, and looking to see what are natural variations in human caused change and how does that affect different layers of the atmosphere and how does that compare to models. So now I want to move to talking a little bit about different things that can be done, because there's a lot that can be done. And actually, there's more tools available now than there were, than we've had in the past. And so that's a positive. And this is photovoltaics or solar cells, onshore wind and batteries for electric vehicles. And the price of all of these has been decreasing pretty dramatically. And physics is used to, um, in order, physics is very important for all of these different strategies. Like for photovoltaics, one branch of physics is called solid state physics, and that's where people try to understand what are properties of different materials, and that's important for creating solar cells. And then wind, the understanding motion and understanding what's happening to a wind turbine and what are some of the best ways of designing a wind turbine would be an engineering problem, but also has physics associated with it too. And batteries, physics plus chemistry as well. This is another website that I wanted to share with you all that has to do with, it's called Project Drawdown. And in Project Drawdown, sorry, before I explain this, I wanted to ask people to put in the chat some ideas that they have for what kinds of things we can do to reduce carbon dioxide and methane in the atmosphere. And I should say carbon dioxide is the biggest source is from fossil fuel production. And another reason why carbon dioxide has been increasing in the atmosphere is because when trees are taken down or where plants are removed from the land, then we have less of them to take in carbon dioxide. So if you all oh, that's an excellent question. So, so if you want to put in some ideas into the chat, please, that would be great. And so, and Denise asks, at what point in the future, how long will it be before the United States experience severe droughts similar to Africa? So this is a really good question, and one again that will, what we can do is, my understanding is that different parts of the United States might experience different, what they call impacts due to climate change. So some would experience more flooding, some would experience more droughts. And this new report that just came out in February, there was another part of the United Nations report that looks at different regions of the United States and the world. I think it's different regions of the US but it is certainly the world. And we can look at that to try to find out more about the timescales that are predicted for when drought might, how severe a drought might be in the United States and when it might occur. And I also wanted to, I wanted to share, I also want to come back to Denise's question in just a moment and maybe broaden it a little bit. So I don't, okay, and then in terms of strategies, Eli says that we should stop using cars that use gas. Yes. So thank you for that, Eli. So one of the approaches now that is, one thing that we hope we'll have more and more of is electric vehicles, but electric vehicles that are powered by renewable energy, like solar energy or wind energy. So where we get the electricity from renewable sources. And other people can continue to put questions and ideas in the chat, please. I wanted to share while I also talk a little bit about this Project Drawdown. So Project Drawdown, we have there talks about a lot of different ways that we as a society can reduce greenhouse gases. And one part of that is reducing the sources of greenhouse gases. So that's the top here. And so, as we said, Eli was mentioning the stop using cars that use gas. So changing our transportation, changing the way our energy is produced. So moving away from fossil fuels, changing some of the agricultural practices and food waste, protecting ecosystems. Another way is to what they call enhance a sink. And what sink means is that's a place where carbon dioxide is taken in or methane is taken in. And this is like including shifting agricultural practices so that they would be more so taking in greenhouse gases, protecting and restoring ecosystems, for example. And you can learn a lot more about these different ideas here, different ways, strategies that can be used to address greenhouse gases. And from this website, this is one of many, but this is, or one of others. There are other websites too, but this is a really good project to look into. And you can also learn about lots of different kinds of associated with these different strategies are a lot of different careers that people can have. And these are some pictures from this last Intergovernmental Panel on Climate Change report, and showing that in the future we could have more buildings that have more solar energy, that are more energy efficient, more community gardens, urban gardens are helpful, and more wind power. Planting of trees is very important, and very important, environmentally friendly mass transportation. Yes. And making it very convenient for people and making it powered on renewable energy. Absolutely. Thank you, Denise, for that. And something that I think is very exciting in terms of one of the proposed policies would be something called the Civilian Climate Corps. And this, if this is enacted, this would be an expansion of the type of jobs that young people could have in working on climate, like whether it might be planting more trees, working in urban gardens, putting more, making buildings more energy efficient. And these can have multiple benefits. So for example, if our buildings are more energy efficient, then our energy costs, like our energy bills, could be less too. So I want to come back to one of Denise's questions and make it a little broader. Denise asks about when might we see, what impacts might we see into the future? And this is a graph that's showing, and then we're almost done with the talk here, but we can certainly wait and ask more questions, talk about more questions and ideas. But this is a graph showing years and on the x-axis, and then showing temperature changes in the y-axis. And this is the black line is the temperature. And then these colored lines are possible scenarios in the future of for what the temperature might be at with different scenarios of different ways that we might use energy, or different changes that have happened in the earth, to society, what our temperature might be at the end of the, what the temperature might be at the end of the century. And I just want to share just a tiny bit for those who like computers, talk just a little bit about computer models. So here we have the black line is the temperature, and this gray region are computer models that have been used to predict what the temperature might have been in the past. So this is what's called hindcasting. We talk about forecasting, like forecasting the weather into the future. This is called hindcasting. This is saying, well, let's use a computer model to try to predict what the temperature might have been in the future, in the past. And that's a way of testing to make sure that the model has the right chemistry and physics and to try to keep improving the model. And this also includes a lot of social science now if we look into the future, because each of these scenarios has to do with like different amounts of ways that we might have transformed our society and at what speed. And so the concern, so if we actually make a very big transformation and in the next 8 years are very, very important, we might be able to try to keep our temperature to within a change of 1.5 degrees Celsius from pre-industrial times, which is amount that the international community has been discussing as a way to try to avoid some of the worst impacts of climate change. But if we don't, if we just keep going the way we are going, or increasing our greenhouse gases, we would have much bigger temperature changes and much more catastrophic impacts, more drought, more extreme weather events, more people displaced by climate change. So we don't want to go there. We want to go one of these, a scenario where we are limiting changes due to the climate, and then also, again, making many other good changes. If we have more public transportation, as Denise mentioned, then that makes it more convenient for people to travel and can make our air quality better and also be good for the climate. So I'll just end with a couple of quotes from the Intergovernmental Panel on Climate Change report that was just released again. So you might have seen this in the news, that this is including that recent changes in the climate are widespread, rapid, and intensifying and unprecedented, and that we really need to limit global warming by making very sustained reductions to carbon dioxide, methane, and other greenhouse gases. And these changes can not only reduce consequences of climate change, but they could also have other positives, like improving air quality, or maybe it would make it easier for people in all different neighborhoods to be able to go walking and go running and go biking. So maybe we have more local food that would be more delicious and also could create jobs for people to grow it. So there's many other positives. And that the future we experience, that the climate we experience in the future depends on decisions we make now. And each of us has a role to play, whether because we need changes from personal level to local level to national to international level. And so whatever you like to do, there's a way to contribute what you like to do in order to making like improvements for the climate and for climate justice and for making a world where we all can thrive. So thank you so much to everyone. And if you have more questions or more thoughts, please keep adding them into the chat. I can certainly stay here. And I do recommend you could go to this website. You can go, as I mentioned, also the Wisconsin Initiative on Climate Change Impacts. The NASA and NOAA are good resources for climate change science. Also, the NAACP has good resources on climate science and environmental justice and how to respond, and the Indigenous Environmental Network. There's many organizations, Union of Concerned Scientists, many organizations that one can look at too. Well, thank you so much, everybody, for coming. And again, I'll stay on for a little bit. And I do know that there's a little bit of delay from the YouTube chat. So I'll wait and see if there's any other thoughts or questions. And I really appreciate your coming. And thank you for your ideas too. And I hope oh, and one other thing I would say is, that because of the time scales and the scale of transformation that's required, it's really important that we also have policy that will make it easier for people to have lives that are reducing greenhouse gas emissions. And a really good example was the one that Denise put in the chat about environmental friendly mass transportation, because that's something that requires policy, that our community has to decide together that we want to put our resources into mass transportation. So that's an example. So it's really important also for us to educate ourselves about elections, contact our policymakers, and thank you again.
Okay, I don't see any other questions, but I see some thank yous from YouTube for the presentation.
Oh, okay, great. Well, thank you.
Okay, I think I will